On this problem, all we're doing is looking for the axis of symmetry and the vertex. We're not going to graph this. We're not looking for the zeros. We're just wanting the axis of symmetry and the vertex. If this is going to work. So far, so good.
Watch your break again.
Please don't.
Zippy.
Wait, what was vertex formula?
Oh no, what was it?
How do you find the axis of symmetry?
B over negative 2a.
Okay, the axis of symmetry is an equation.
Oh, is it the vertex?
Oh, wait, no. Here's what you do. What you do is you find the vertex and you plug the point into the equation.
Okay, what is the equation for the axis of symmetry?
I don't know anymore.
X equals negative b over 2a.
Oh my goodness.
Oh yeah, because the answer is x equals the answer.
Okay, the axis of symmetry of the parabolas we're looking at is a vertical line. A vertical line has the equation x equals some number. Okay, so for this problem, let's plug our stuff in. X equals negative b. That would be
Negative 4.
negative 4 over 2 times a, 4. Negative 4 divided by 4.
Negative 1.
X equals negative 1 is the axis of symmetry. The axis of symmetry is not negative 1.
No,
The axis of symmetry is x equals negative 1. Okay?
That's it?
The vertex.
Divert.
How do you find the vertex?
Oh,
It's f of
Your axis is
negative
symmetry.
1.
negative 1. Plug that in. 2 times negative 1 squared plus 4 times negative 1 plus 5. Negative 1 squared is 1 times 2.
2.
2 minus 4 plus 5.
Negative 7.
Probably not.
I did the math wrong. It's 3.
3. Okay, so where's the vertex?
At negative 1, 3.
The vertex is at negative 1, 3.
Yeah, I did it.
Okay?
I feel like it was impressive.
Yeah, that's a lot simpler than completing the square and yada, yada, yada.
Yeah, a little bit.
When you see the word models, that introduces the fact that we're going to be working with word problems. Okay? Because the vertex of a vertical parabola is the highest or lowest point on the graph, parabolas in the form y equals ax squared plus bx plus c. Once we find that maximum value, the maximum value is going to fall on the vertex. Where is that maximum or minimum value going to happen? That's going to give you the x value. So x value, the axis of symmetry, tells you where that's going to happen. The y value tells you what that maximum or minimum value is. Here's the start of a problem. We're going to neglect air resistance. The height in feet of an object projected directly upward from an initial height s sub 0 feet with initial velocity of v sub 0 feet per second is, and it gives us this equation. S of t is equal to negative 16 t squared plus v naught t plus s naught. Okay? V sub 0, v naught, s sub 0, s naught. That's how I read it a lot of times. Anytime you see a subscript 0, that indicates beginning. Okay? V is velocity, s is initial, or s is height. T is the number of seconds. The coefficient of t squared, the negative 16, that is a constant of gravitational force on Earth at sea level. We're going to use that equation. Here's the first problem. A ball is projected directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. Give the function that describes the height of the ball in terms of time.
So would you plug in 100 for S and 80 for V?
Sounds great. So S of t, the height of the ball, is going to be negative 16t squared plus initial velocity 80t plus initial height 100. So we're ignoring wind resistance and everything. So basically, here's what's happening. I'm standing 100 feet in the air, maybe on a building probably.
What if it hits a bird?
Okay, weird stuff going on. I throw the ball up, the ball comes down. Right? Throwing time in there, here's what's happening. I throw the ball up and the ball comes down. That's straight up, straight down. Okay? If I was graphing this, I started at 100 feet above the ground. So here's the ground. What's this here?
The apogee.
Axis of symmetry.
Okay, that's going to be your axis of symmetry. That's going to be the highest point. How long did it take to get there? We're about to get to that problem there.
Just saying, I was technically right.
Unless you can throw something and put it in orbit. We're not going to talk about apogee and perigee. Okay, part B. After how many seconds does the ball reach its maximum height? And what is that maximum height? What are we looking for?
What the max? We're looking for the vertex.
The vertex. That's all we're doing. We're looking for the vertex.
Yeah.
Okay? So to find the x value of the vertex,
X equals -3/2.
which is the axis of symmetry, plug our values in. Negative b would be negative 80 divided by 2 times negative 16 is negative 32. A negative divided by negative is a positive. That's a good thing. It's going to happen after it's released, not before.
Is that 5/2?
Yeah, it's 2 bits. 2.5. 5/2. 5/2 isn't as meaningful as 2.5 in this case. Okay. How long did it take that ball to reach the maximum height?
2.5 seconds.
2.5 seconds. How high is it?
You have to plug it into the equation to find out.
Okay. S of 2.5 is negative 16 times 2.5 squared plus 80 times 2.5 plus 100. Once you plug that into your calculator, you find out that S of 2.5 is 200.
Cheater.
Okay? Now, this question has 2 parts to it. It's a word problem, so we should answer a word problem with a sentence, and we can answer both questions in one sentence. It takes 2.5 seconds for the ball to reach a maximum height of 200 feet.
Check it for a ball under the
You're shooting ball 100 foot up. So we didn't throw the ball 100 feet up, right?
No.
We only threw it 100 feet up because we started at 100 feet. Right?
I think you said that.
Yeah.
So did we throw the ball 100 feet up?
We didn't throw it 200 feet up.
But you said 100.
You know what I meant.
Did I though?
You probably not.
Tyler didn't.
Okay, I'm the one that corrected him, so if anything, I am the one who knew.
We good with that?
Never mind.
Next question. For what interval of time is the ball greater than 160 feet? So obviously, if that ball is thrown up and it hits 200 feet, at some point, it's got to hit 160, right?
Yes.
And it's going to stay above 160 till it's coming back down and it crosses 160 again. Any thoughts on how you go about solving this?
Calculator. It works.
I agree.
That's true.
Okay.
I realized what you said.
Do what?
Plug in 160 to X.
Yeah, S of t. Right. S of t represents where the ball is at any given time. So we want the ball to be at 160. We don't know the time. So here's how I'd write this. Negative 16t squared plus 80t plus 100 is greater than 160 maybe?
Equal to,
I don't like that.
because it's
How does
greater.
that make sense?
Oh, wait, no, yep.
Okay. And how would you go about solving that?
Solve? They're not right, just
I don't know.
Solve it.
So they find time.
Yeah. You want it to be 0, right? So then you read that 160 over. Subtracting 160 from both sides, I have negative 16t squared plus 80t, 100 minus 160.
Negative 60. Oh my god.
Now we can quadratic formula that, maybe factor that. I would probably factor something out of that to make the number smaller.
8,
2.
4.
4.
Negative 4? If I take a negative 4 out, 4t squared minus 20t plus 15 greater than 0. Those numbers are a lot smaller, so quadratic formula will work nicely there. So starting off with the discriminant, b squared minus 4ac. That would be negative 20 squared minus 4 times 4 times 15.
400 minus 240.
So the discriminant is 160.
That's another square root. Or it's not a perfect square root.
That's not a perfect square, but 160 is 16 times 10. And the square root of 16 times 10.
Is 4 times the square root of 10.
Okay. Now quadratic formula. X is equal to negative b
Positive 20.
Okay, so x equals positive 20
Plus or minus 4 times square root of 7.
all over 8. Okay, that's two different answers. When you plug them into the calculator and round them, you find out that x is 0.92
What am I putting in?
and
Like the whole equation?
that.
Okay, give me a second.
Wait, how do you do the plus one?
Oh, duh, you're not
It's
doing
two
it.
separate problems.
Yeah, I guess I didn't say that.
So when you do the 20 minus 4 square root of 10, get an answer, divide that by 8, it rounds to 0.92. If you do 20 plus 4 square root of 10, and then divide that answer by 8, you get
Working on it.
Is it 5.08?
I don't know, I forgot to put in the 4.
Good job.
Y'all calculator's not me.
It's 17. Just kidding.
You should have the brain and calculator.
Oh God, why is it taking so
Because I keep forgetting to put in things. I don't hear it, one of you
Yeah, because we're better than
and you would be doing it. 4.08.
4.08? Okay. Do those values make sense? Is 2.5 halfway between those two values?
Yes.
How do you
Yes.
find if it's in the middle or not? It's the average, isn't it?
Yes.
So 4.08 plus 0.92 is 5, and half of 5 is 2.5, so we're good. Okay, what about the calculator?
What about it?
What about the calculator?
You want to explain to us what you mean by?
did we even answer
Wait,
the
what?
question?
Oh, are you asking like how can you put this into? Okay. Never mind.
Yeah, we answered the question. When is the ball above 160 feet?
Between
What's-
1.92 and
What's interval time?
Between 0.92 seconds and
4.08.
4.08 seconds.
Sometimes like a certain amount of time, how to put it in.
Okay,
Oh.
Is it 08?
We're looking for height in the whole.
negative 16x squared
4.08.
plus 80x plus 100. That is the equation of the path of our ball, correct?
Yes.
Okay. We've done some math with it already. Is the ball ever going to go below 0?
No.
Right? It's probably not going to penetrate the earth. So before we look at this graph, we want to go to our window and start thinking about it. We'll start with y. The ball cannot go through the ground. So we'll say that the lowest value for y is 0. And how high did we determine our ball was going to go?
200.
200. Okay.
Yeah.
And do you want to count by ones? You also be doing this on your calculator if you're not used to changing windows. Okay, just watching me is not going to be good for you later on. You're going to be asking me how to do this, and I'm going to say, well, why didn't you participate in class?
Wait, 1 second.
Okay, what do you want to count by on the y-axis to get from 0 to 200?
25.
20.
20, 25, either one of those would work fine. Okay, let's talk about time.
It has to start at 0.
Okay, yeah, we're not going to talk about throwing the ball up in the past. Okay? Now, in finding the time that the ball is above 160 feet, we found that it's between 0.92 and 4.08.
Yeah.
Right? When do you think it's going to hit the ground? Just guess.
7.3 seconds.
Okay, so 7 seconds, 8 seconds. We don't really know, but okay, let's go 7. Is it okay to count from 0 to 7 by ones?
Yes.
Sounds great. How's your graph look?
My graph looks pretty good.
Do you see it all?
I can understand.
Does that look good?
Yes.
Okay.
So it stops at 6.
The question that we just did asked us when the ball was above 160. So what if I went into y equals and I said, okay, well, y1, that's the path of my ball. I want y2 to be 160. That's just a horizontal line, right?
Yes.
And that's going to cut the path of the ball. Can you see where the ball is above 160?
Yes.
Can you calculate those two values? Can you tell me exactly this x value and exactly this x value on the calculator?
Yes.
Yes.
How?
By
Say that again? The intersection. Okay?
yes.
So if we go to calc, second calc, I want to calculate the intersection, number 5. It's going to ask 3 questions. First curve, second curve, and guess. Okay? By default, first curve is going to be y1. press enter. Second curve, Y2, press enter. Guess. Wherever the cursor is, it's going to give you the intersection closest to that cursor. So if I press enter right now, it's not going to give me this intersection. My cursor's here, it's going to give me that intersection. Does that make sense? I press enter. I don't care what order I do them in. Is that what we got using the quadratic formula?
4.081138883.
Okay? And to do the other one, second calc, intersection, Y1, Y2. I need to get closer to it. I'm closer to it. 0.9188612.
611,699.
Questions on that? So between 0.92 and 4.08 seconds, the ball is above 160 feet. Next question, when does it hit the ground?
Good question.
When does it hit the ground?
6 seconds.
Oh, can we use the calculator to find?
Hits the ground right there.
630.
Okay, is that an intersection?
No,
What's this called?
exit.
Another name for X intercept.
Oh, root. I don't know.
Another name for root.
Zero.
Zero. Okay. Calculate the zero. I am obviously, the zero's right here. I'm clearly to the left of it, so I'm just gonna press enter. I now need to go to the right of it. Sometimes you can hold it down and sometimes you can't.
I'm holding mine down.
There we go. And I passed it. Press enter. Guess. I just go to the left a little bit. And there it is. So how long did it take that ball to hit the ground after it was?
6.0 seconds.
6.035.
Okay, about 6.04 seconds.
Yes.
Okay, piece of cake. You could also use the Pythagorean theorem on the original problem, and that's going to give you the zeros. Quadratic formula. Let me go home. You can use the quadratic formula on this, it'll give you two answers, right?
That was funny.
I love the best part.
I
is
thought you
nobody
were
decided
joking
to
at
like
first.
say you said it wrong. We just laughed.
Isn't this the second zero over here?
Yes.
Yes.
Does this zero make sense?
No.
No,
So we
it's.
throw out that one. So
Yes.
after you use the correct formula, I think it's called the quadratic or something like that. Once you use that quadratic formula, you throw out that minus one. Just keep the positive, what's gonna give you over here, this is 6.04.
A lot more things you have to.
I thought you were like joking that time.
Y'all are jerks.
Then I
Did it
realized
to
you
yourself.
weren't. Are we gonna start this problem?
Okay. Go to stat and enter this data.
Wait, just a split second.
7+712 is what?
Are we putting in the year?
No, stat didn't want.
She's really aggressive.
Oh my gosh, yes we do.
I'm gonna have to edit this
I'm
video.
tired.
Do you edit the
Do you
videos?
actually edit them?
I'm planning on using these on my college course.
You can
Good luck with
probably
that one.
like.
It's gonna be no stack.
I'll probably just ignore this video altogether. Okay, enter your data.
Wait.
By the way, yes, you do put the
Oh my
year into
gosh.
stat. By the way.
Do you have the video of my drink exploding in my face?
Why did I get to see that?
I want to see that. Why are you doing it so fast? That's annoying.
Yeah, it's throwing me off. I can see it. Wait,
Wait, how do you type so
why'd you go to
quick?
109?
How are you doing it so quick?
Half a second for
Little
my
did they
face.
know.
Holy crap! Did we just go to
How
109?
far do we go?
All of
You
them.
calculator nerd. You've done this before some way. You've done like what are those jobs accounting?
It only goes to 105. Oh, it doesn't.
Hey, buddy, you're going real far.
I just use yours.
Oh, that's all, I was about to put that in a fourth.
Is this how we find out this stuff? Ow!
73.5. Oh, I thought you.
I hate you, best friend.
2.7.
You're gonna have to slow down. Just take a breather.
Oh, wait, 107. These nails aren't helping.
I was just double checking my data, make sure I typed it all in right.
Did you?
No, I typed the second year and the third name.
Hey, good thing you didn't type in the quadratic formula.
Stay with the Pythagorean theorem.
Okay, this one's just gonna be absolute not okay.
6.9.
So I don't have exactly the same tools you do. You know.
9, 1, oh.
Can you not use the, you don't have a 10 key on your,
No.
you just have the one down across the top.
Yeah.
You're gonna fast one in by the time.
Yeah, we're like really.
I finished.
you just
Yeah,
go,
I don't know why
you
you
did it.
made this.
We can watch you.
Yeah, you should just do it.
We'll wrap it up tomorrow.
Okay.
I typed
Sorry,
it.
I just read all this in for nothing.
Mr. Rory! That's why I asked why
I
are we
went
doing
so
this?
quickly.
And if you ever make fun of the Pythagorean theorem again, I'll punish you some more.
I hope